So just a little bit of further explanation. When we looked at the sine law for lesson 5, we had a strange phenomenon occur with one of our examples, and that was with the last example. So here in the last example, we actually ended up with two different possibilities for this triangle. And I just wanted to explain a little bit more about why that happened. So there's something called the ambiguous case. The ambiguous case can occur in some triangles that look particularly like this one that we did in example 3. So in the other examples that we did, we were kind of checking to see if there would be more than one possible triangle. In this last example, it actually turned out to be true that there could be two possibilities here. So this always happens, this ambiguous case occurs when we have side, side, angle. So when you're given an oblique triangle, so not a right triangle, and we have a shorter side, a longer side, and then an angle. It doesn't have to be in the exact order that you see here. It could go side, side, angle. But it does occur that there's a shorter side, a longer side, and then an angle given. So sometimes it's written like this: side, side, angle. I've seen that before. Lowercase s for the shorter side, that would be our 11. Bigger side is our 20, and our angle is the 30 degrees. So it just so happened that this was the only triangle where that occurred in our lesson. When we look back at the other examples, there was a side and then a side, but the angle was across from the longest side. So there was no ambiguous case there. Example 1, there was a longer side, a large angle, and then another angle over here. So we didn't have two sides. So the ambiguous case occurred in example 3. So just take a look at this. This is a little demonstration as to why this occurs. So here's another triangle, a different one. We have side, side, angle, right? Short side, longer side, then an angle. So what will happen if we actually take this length that is 6 and we move this side length? We could actually have a second triangle that appears over there. So this is a fixed length, and this 13 is a fixed length, and the 20 degrees isn't changing. So how do we know for sure that this is how the triangle should be drawn? This side length could also be there. So in that case, angle C has two different options. It looks like a smaller acute angle if BC is in this position, and angle C is going to change to an obtuse angle greater than 90 degrees if BC is in this position. So this is called the ambiguous case. There are two possible answers for angle C, meaning then that there would be a different side length for AC, and angle B would also have a different measurement.